Okay, I'm Rob Tiffany. I'm going to blame everything I'm going to talk about on Ryan from the last deal because he talked about the tech stack to do this stuff. And so everybody in here is way smarter about this stuff than me, but I do know how to build the tech stack. So this is going to be a technical session. I'll try to go fast so we can go have lunch. It'll be really geeky. So here we go. It's IoT, which I've been doing for too long. So building this greenhouse sustainability platform. You know, when I think of emissions and stuff like that, I've built technology and writing about all the 17 sustainable development goals from the United Nations. And so climate's just one of them. I build technology to go after all that stuff. Hunger, poverty, water, climate's just one of them. Spent a bunch of time at Ericsson doing 5G and IoT. Did the industrial IoT stuff, which is really hardcore. That's where most people are spending this. If you're here about Industry 4.0, that seems to be the big thing these days. And then spent most of my career at Microsoft. So I flew down from Seattle, but I am from Houston originally. So I'm one of you, kind of. I grew up here, but yes, I had to live up in Seattle for a long time. So what are we going to talk about today? What in the heck are fugitive emissions? We're going to keep it simple. We'll just stick with CO2 and methane. I'm going to talk about that stack, connected intelligence stack. I won't call it an IoT or analytics stack. And then I'm going to kind of talk about how to quantify it in terms of oil and gas, upstream, midstream, and downstream. So this session is really techie, but it's more about the how. And if you were crazy enough to say, I'm going to build my own stack, this might be how you would do it. I apologize to all the tech providers over in the other room who might feel like I'm competing with them. So fugitive emissions, right? It's just these releases of different gases and vapors from pipelines, from wells, from all kinds of places that we don't want to have happen. And it's just, you know, we're getting tons of it a year. And the way things are today is people, and this is how it is in IoT in every use case. How do we do things today? Someone goes and visits a location and takes a reading, a measurement. And maybe they write down that measurement on the clipboard and then they bring it back to the office. Maybe they're doing something more sophisticated than that. But we've got great sensors and wireless networks and stuff like that. And there is definitely a better way to do this, and it's not rocket science. How do I, oh good, now it's counting down so it knows when to throw me off the stage here. Okay, so let's just talk about the stack, okay? So we can do continuous monitoring, right? That's what we want to do. We don't want people getting in a pickup truck to drive to a terminal to go take readings 4 times a year times X number of locations, which costs a lot of money. Let's just let the technology do it for us. So here's your obligatory Peter Drucker slide, which you probably get beat over the head all the time, but I'm a fan. How are we gonna solve all this stuff, whatever the problem is? You've gotta measure it first, right? So you can manage it, and then you have a baseline and you know how to improve it. So that's kind of the why of doing this. And so what are these components? Well, we've been all talking about sensors. Sensors are out there to measure whatever it is you're measuring, parts per million of some kind of gas. You need networks to transport those measurements. You've got cloud computing, if that makes sense, when you're going across wide areas and large sets of data. But sometimes you're doing edge computing when you want to process things closer to the source, or maybe you don't have the connectivity you need. Digital twins, I'm a big fan of those. I started doing those a long time ago in modeling machines in factories. But that's how we model these systems. The things that you're monitoring, you know, a tank, a wellhead, whatever, things like that. Analytics, it doesn't always have to be rocket science analytics or some kind of neural network. I find in most cases, those simplest analytics actually move the needle the most. Automation, that's where you take actions on insights, right? We gotta take action. Obviously this whole event is about reporting, but taking action is better than just reporting, I think. And then of course you have to wrap that whole thing in security or it's no bueno. And of course nothing happens without people. All the SMEs, all the smart people in this room are the ones who would drive what KPIs look like. They should drive what the analytics look like, not some tech person. So let me just kind of throw some Lego blocks together from left to right. You know, the physical twins, the tank, the wellhead, the tank car, the truck, whatever it is the thing is. And you've got devices out there because you can't just have sensors. You have devices with electricity and network connectivity and actuators and sensors. You've got short range wireless. You sometimes will use edge computing out there when you can't always reach back to a cloud. You've got long-range connectivity. It could be cellular, it could be LoRa, it could be something else. And then you've got these platforms that we've all seen. There's hundreds of IoT platforms living in Azure and AWS. GCP's shutting theirs down, but PTC, there's lots of them out there, right? And they do a lot of these things for you. These are kind of generic platforms to address lots of use cases, but they're perfect for this kind of use case, right? So what do we start with? It sounds really stupid and obvious that I'd say you need electricity. I can't tell you how many people don't think about that. I probably didn't think about it. I spent most of my time doing this whole smart factory thing and building these factories of the future. And you don't think about it. It wasn't until I started doing IoT in agriculture that I was like, oh, wow, I guess we need batteries that last a long time and low power and solar and stuff like that. It's always good to go out on the farm and find out, where the real hard work actually happens. Devices, I apologize, this does not look like a sensor for emissions. I just threw this in here. This is actually a prototype sensor that I used in agriculture, but you kind of get the idea. A lot of these devices can do a whole lot of different things. The ease with which you can deploy these things and get them up and running and connect it to some kind of platform is part of the key to success. Networks. There's no shortage of different types of networks out there. Most people just think of the obvious long-range things like cellular, satellite. Starlink is really helping us out when we're out in the middle of nowhere. Satellite always used to be the most expensive way to do things. But there's short-range stuff. People are always talking about, I need real-time data. And I was like, stop talking to me about that when you have to use a RS-232 serial port to talk to a PLC. There's nothing real-time about that. That's like 1980s kind of stuff. But there's so many choices. When you think about the stack, these are all the things you have to think about. And later in the session, I'm going to just bore you to death by drilling into every use case that you can think of and which ones you would choose, because it's almost just like making choices throughout. So sometimes you're doing cloud computing. If you got good connectivity, you want to put the platform up there, maybe one thing to take care of everybody. You're not worrying about latency. Sometimes you want to do edge computing. Maybe I can't connect to the cloud. Maybe I need to push analytics right to the edge, like right there at the wellhead, the pad site, to take actions. I can't wait. And so, you push it out there because you don't have great connectivity. Computer vision, we all talk a lot about computer vision these days when you think about flaring, right? You're probably beaten over the head with that. Edge computing is great though. I love just rationalizing data. People talk about different data formats and interoperability and things like that. There's so many under the sun, it's crazy. And so having a way to just rationalize a zillion different formats into a single one that you can work with and understand. So let's move along here. Does anyone know about digital twins? Okay, like 10 people. Excellent. This is really geeky stuff, but it'll be weird for me to say, but it's super important because you're like, I don't even know what that is. It can't be that important. When I was at Hitachi building this industrial IoT technology for factories and bullet trains and stuff like that, it became clear to me that having that modeling kind of thing where you actually can do accurate high fidelity models of the thing you're monitoring actually is kind of important. Those of you who've been to a digital twin session, you've probably seen someone talk about, hey, do you remember Apollo 13? When Forrest was up there in the spaceship and, Lieutenant Dan was in Houston and they were solving that problem with the spaceship and everything, and they're trying to figure it out. Luckily, we had a physical twin to that spacecraft. But after that, NASA realized moving forward, we're going to need high fidelity digital versions of a spacecraft. So digital twins have been kind of a nascent technology, primarily in manufacturing for the last 20 years. But the way I know that it's hot now is I'd say last year in 2022, a day didn't go by where somewhere in the media I saw the words digital twins. I won't beat you over the head with it, but it's exactly how we model telemetry and commands and everything. And it's not just a model. A lot of digital twin conferences I go to, they love to show the 3D model of the offshore drilling rig. The twin is alive. IoT is the plumbing that's feeding telemetry into it, and so it's a living thing. And then you're analyzing, and you got the latest state and the historical state. And this is what we're going to do with emissions, right? The twin could be the tank, right? And then the ongoing stuff is emissions. That's like the simplest scenario you can imagine, right? Analytics. This whole this whole conference is actually just about the easiest analytics. It's just called descriptive. What's happening? That's what reporting is. What's going on? What did I get? Do I need to massage stuff? Did I capture parts per million, but I need to change it into some other format, like metric tons or whatever? Yeah, but it's the easiest stuff. None of this is rocket science. Obviously, diagnostics is a little deeper when you're trying to solve problems like, Forrest up on the spaceship, right? Predictive analytics is what everybody loves to talk about. Predictive maintenance, everybody's been talking that, just beating you over the head for the last 10 years in manufacturing primarily. Fix it before it fails, right? Seeing trends and going into a certain direction, where sometimes maybe you do need machine learning. And then prescriptive. Once this happens, what am I supposed to do about it? If you think about this just like going to the doctor, I've got something weird about me, and the doctor is looking at you, and he's kind of got that descriptive thing happening, and then he's kind of analyzing based on all the years in med school and said, I think it could be this, and then your prescription is this. Go to the drugstore and get it. It's just the same thing. But it's also why important when we talk about the importance of acting on insights, is make sure that you've got that list of things to do to probably take actions on insights, not just always report them. Automation, I don't know how relevant automation is to a reporting conference, but automation is typically the last step. We do things as humans manually, but the only way we can do lots of things really fast exactly the same way is through automation, right? And so when you think about using this kind of technology to take actions, ultimately, you don't want people involved. This will be in the future, but ultimately it's going to make decisions, it's going to take actions, and it's going to do automation. Like if I was back on the farm, right? And my moisture sensor told me, hey, it's time to water these crops in the hops field, or we're not going to be able to make beer and IPAs. And so you just automate an irrigation system. None of this is too hard to do, but we can do this across all these systems, and that's how we can scale these systems. And then of course, security. You probably have heard zero trust 1,000 times over the last couple of years since it came out. That whole system, as you're building your stack, if you're not wrapping that whole thing in as much zero trust security as you can, you could have a rainy day. We all talk about digital transformation, Industry 4.0, it can derail all that stuff. Hackers, it can end the whole thing for you really quickly, and all that money you spent just is worth nothing. So having that security at every stage out there, if it's at the drilling site or wherever it is, at the sensor level, the device level, the network, if it's at the edge, re-authenticating all the way through. It sounds mundane and stuff, but that's kind of how you do zero trust. We don't trust anything anymore. We have to keep verifying that you are who you say you are, or your data packet is what we thought it was. So, how do we quantify these emissions? And where should we monitor? So you've seen probably pictures of these. These are kind of some of the devices you might use to monitor or determine if there's methane out there. Do the easy one first, though. Obviously have cameras out there just looking for cracks. But then we do infrared detection of things for CO2, and we know how long that lasts. And then, of course, methane lasts less long, but it's 80 times worse than CO2. But we do infrared detection. But there's other ways. There's all kinds of sensors that can do these things. And nitrous oxide, it's kind of a horror story there, isn't it? But we have the technology. Just like the $6 million man, we can do this. We've got the technology, we can put it out there, and we can automate it and have it do it real time. Scope, this would only be a slide I'd have if it was for a group that wasn't like you, because you're all experts at this, so you already know what scope 1, 2, and 3 emissions are. Scope 1 is your stuff, right? You're the reporting, you made it, it's coming from you. Scope 2, those indirection. I purchased energy or something to run my thing. So a lot of times I'm the creator of the emissions and I needed energy to run my thing that's also emissions. So maybe you're scope 1 and 2 at the same time. And then everybody hates talking about scope 3. But I'm gonna take a chance in the next few slides before we go to lunch where I'll talk about different scenarios and I'll take a chance on what I think might be scope 3. Feel free to shoot arrows at me. I'm sure I'll be wrong, but you gotta try, right? So let's just walk through upstream, midstream, and downstream and look at different use cases. Think of these slides as almost more of a reference for you in case you wanted to know how to go do this. I might not be 100% correct, but you got to start somewhere, right? So we'll start upstream. We're drilling. It's probably scope 1 and 2. You're making emissions from your action of drilling, and guess what? You got electricity because you got a nearby diesel thing creating power for you to run that operation. So what I'm trying to do here, you kind of see this kind of chart, this grid at the bottom. All the slides I'm going to show you here for the next few minutes are going to look like that, but they're different variations. And that's why I say this is more reference slide for you just to keep with you, because it'll start to look really mundane because they're going to look the same. But you can imagine I'm going to model that whole rig system and the generator that's creating energy for me. You talk about what you're measuring. Why do I care about pressure? Oh, that was that whole predictive thing. Like the pressure starts getting crazy, maybe something bad's going to happen, right? So you do ionization for that. And so it's important. What am I measuring? CO2. What's the unit of measure? Well, typically out there, I know we're talking about all other kind of measurements, global warming potential and metric tons and things like that. But actually, most times your sensor is going to tell you, well, the actual reading is it's this many parts per million is what I see out here in the atmosphere when I'm reading that kind of stuff. Devices, if you're on battery, you need to use a microcontroller that uses less energy because it's going to have to live out there for a long time. And you'll use low power things like LoRa WAN potentially for wireless because it doesn't eat a lot of energy. If you do have electricity you can plug into, then yeah, maybe you could use a larger device to sensor to do that. Networks, you'll have a local network there potentially. You might have Ethernet or you might have Wi-Fi, but then ultimately you've got to get it somewhere. You might have to do satellite backhaul. If you're lucky, maybe you can do cellular. You never know. And then that cloud, that compute and storage, you'll probably be caching and doing a lot of stuff at the edge, especially right there in that kind of scenario because you're way out in West Texas. And so you'll do that and then maybe send the rest of it to the cloud. So moving on, offshore is going to be kind of similar, except probably not cellular, right? But a lot of the things here you'll see are the same right up until we get to the end. A lot of times the network communication is where things get weird, right? And so you might have to use satellite. You might be able to tap into some fiber on the bottom of the ocean. You never know. Kind of like, no, that's a whole other story. I used to drive submarines. I used to be in the Navy. And so a long time ago, like during the Cold War, we tapped into undersea cables, and that's how we found stuff out about those guys over on the other side of the world. It really helped us out. It's always good to know what's going on. So anyway, scope 1 and 2 for these guys. If you're doing oil sands, up in Canada and stuff like that, it's another remote place. These are the kind of things you're doing there. You're probably going to be on battery for a lot of stuff like that, so you'll use microcontrollers. Does anyone know what LoRa is? I'm just saying things, assuming too much. We all know what cellular is because you have a smartphone. There's a different kind of wireless connectivity that's super low power. It's just for sending just little tiny bytes of data, maybe 50 bytes. I have lots of friends who work in that industry, and it doesn't use a lot of energy. So if you need to have a lot of devices in a place where you don't have electricity, you're probably going to use a low power microcontroller with low power sensors, and you'll use LoRa because you're not sending a lot of data. I'm just sending, every minute, every hour, every whatever. Even if I send it every day, that's still better than the 4 times a year someone's going to drive out there and take a reading, right? It's continuous monitoring. Anyway, doesn't use much energy. It can last 5 to 10 years on battery. So that's huge. Remember, when you think about this stuff in general, every time you have to go visit, like if you deployed, let's say you deployed a whole bunch of devices and associated sensors all over Texas, monitoring all kinds of things. You want that battery, you don't want to ever have to go visit that thing. Every time you have to get in a truck and go visit that site, it starts to kill your ROI for all the value that you're getting from that starts to diminish rapidly because of the cost of you getting in a truck and the fuel to go somewhere can kill, if you think about the data, little tiny invisible threads going through the sky from all these places, and they're worth so much money, actually. And so when you have to go visit it, it kind of kills the deal on that stuff. Pump jacks. Pump jacks, obviously you're looking at those, the downhole pumps, natural gas generators to keep those things going. You're probably going to be on battery out there. You probably use something like LoRa to get to a place where you can hop onto the internet and you'll do edge computing. See how boring this is getting already? It's like the same stuff, but it's a roadmap. That's what it really is. And then we can go eat. Flaring, everybody loves to talk about flaring, computer vision, seeing flaring happening. Let's not have it happen. That's definitely scope 1. And a lot of it, that's a more simpler one, but having computer vision cameras just looking at that stack to tell you when that's happening. Hopefully it'll happen less and less. So midstream, things like transportation of energy, of fuel, gas, whatever, pipelines. When I talk about the twins, it's like, where do I care about looking at it? It's at probably those interconnects or the different compressor stations that are gonna help keep moving it along. I'm looking for the same stuff. I'm also checking pressure. I'm probably gonna be on battery because those pipelines go forever. To be real geeky with that LoRa stuff, there's this way you can kind of daisy chain, if that makes sense, your way back home. If you don't have cellular, you don't have anything, you can put those along the pipeline and they can just keep hopping all the way down the line until they get somewhere where maybe they can get to the internet, right? Oil trains, kind of similar there. They're out there. If they're in transit and you need to get some information off there, you might have to do satellite or something. When you're in the rail yard, though, maybe you can connect to Wi-Fi. When I was at Hitachi, we built loT, this industrial IoT platform. We put it on bullet trains. You hear about edge computing, but we made sure this thing was portable. And so same kind of thing. We had to be on a Hitachi bullet train in Japan with about 40,000 sensors streaming telemetry continuously to this one thing riding on the train. If you're in transit and there's a problem, yeah, you might be using LTE or something like that. But most of the time, once you get into the next train station, you would hop onto the Wi-Fi and start uploading from there. And you'll do the same thing for these guys here. Super tankers, probably gonna be, well, we'll see. Could be Ethernet throughout the whole thing, could be Wi-Fi. You could do LoRa and hop around just for all the compartments on the ship. But then most of the time, you're gonna be using satellite backhaul until you're in port. Tanker trucks, again, probably cellular most of the time if you're on main highways. If you're putting things in an aquifer, a salt dome, things like that, again, it's gonna be battery powered, probably cellular or satellite. Oil terminals, similar. Depends, they may have electricity right there, they may not, but you'll be doing that. See how boring this is getting? But you're gonna take this with you and build your own stack, so it's gonna be cool. And it's gonna be like your guidebook. Oh, I do this here and I do this there. So downstream, we're almost done. We're almost gonna go have lunch. Refining, you probably have electricity there. You probably have Ethernet and Wi-Fi and stuff like that. You might connect to MPLS network or fiber or cable or something like that to get the data somewhere. But you're gonna do a lot of stuff at the edge. Remember, the speed of light is really slow. And so being close to the source of things means you can do it in nanoseconds or milliseconds versus a whole second or 10. It just depends on, if you're building a control system, control systems have to react instantaneously. That's why we don't send things to the cloud. It's always funny when you talk to people about autonomous vehicles and connected cars, and they go, well, yeah, all the cars are gonna go, they're noticing they're about to have a wreck, and they go talk to the cloud, and it's gonna tell them if it should deploy the airbag. No, it's gotta be at the edge. It's gotta make those choices there. And then last but not least, we get to the gas station, right? Before we put it in your car. And of course, that's scope 3 too. And of course, in your car is scope 3. They probably have electricity. They've got everything at Buc-ee's, so you're good to go. And you can get some jerky and some other stuff while you're there. Anyway, all this kind of stuff. I've been in the IoT space for so long, building these global cloud systems. I kind of built a smaller system just for all kinds of sustainability thing. I call it Greenhouse. And so it goes across all those sustainable development goals, but you can see it's an easy way to plug in. Yes, I'm monitoring this, and here are the KPIs, the ranges that I care about. You always want to help your downstream analytics by telling it all these labels up in advance and telling it what data type it is and what kind of unit of measure. I know this sounds mundane and boring, but everything you do in your downstream system capturing data is to help your analytics make good decisions. Everybody who's in the data space or data science, they know that none of the stuff matters if you have bad data. And a lot of times you have bad data. There's a whole lot of people that all they do is clean data. Anyway, any questions for me? You want me to guess what lunch is? All right. Well, thank you so much for your time.